Today we will see practical number 12. The aim of practical is test the performance of differential pulse code modulator means DPCM modulator and demodulator circuit. In this circuit we will study DPCM modulator and demodulator. DPCM stands for differential pulse code modulator. Now we will see a practical significance. The DPCM technique mainly uses speech, image and audio signal compression. The DPCM conducted on a signal with a correlation between successive sample levels to the good compression ratios. The samples which are highly correlated are encoded by PCM technique, leave redundant information behind. To process this redundant information and to have a better output, it is voice detection to take the predicted sample assumed from the previous output and summarize then with the quantized value such as it process is called as a DPCM technique, means differential pulse code modulation technique. In DPCM we can actually perform decide what will be our future sample according to a present and previous sampled signal. This practical is designed to explain how different types of information signal which are analog in nature and can be converted into a digital form, means in that we can provide input signal, information signal which is in the form of an analog in nature, and we have to convert that signal into digital form, means 1-0 form. Now here theoretical background required for this practical is a differential pulse code modulation is a signal encoder that uses a baseline of pulse code modulation but adds some functionality based on the prediction of sample of the signal, and input can be analog or digital signal. In that we can predict a future sample based on a present sample and previous sampled signal. If the input signal is a continuous time analog signal, it needs to be sampled first so that a discrete time signal is the input to a DPCM encoder. By taking values of two discrete time signal is the input to a DPCM, means we can add a previous sampled output to a one input of a difference amplifier and second input is a present information signal. By taking the values of two consecutive samples, if they are analog sample, quantize them, calculate the difference between first and next, and output is the difference, then it can be further entropy encoded, or instead of by taking difference relative to a previous input sample. Taking the difference relative to the output of local model of the decoder process in the option, the difference can be quantized, which allow a good way to incorporate a control loss in a encoding. Now here block diagram of DPCM transmitter and receiver section is given. First one is a sample, at that x of t is the original information signal, and at the sampled output at the output of sample block we can get a sampled output. Then this sampled output is mixed with predictor output and these two signals are quantized. After that the quantized output is applied to a encoder, and at the output we get a encoded signal which is in the digital form. The reverse process is used in a DPCM receiver. Here the received signal is in the form of a digital nature, so we have to use decoder to convert it into analog form, and this analog signal is matched with or is compared with predictor output, and the resultant signal is applied to a low pass filter, and the output of at the output of low pass filter we get original information signal, that is continuous time analog signal. Now we will see the practical. For this practical, the resources which are required. First one, we require a CRO or DSO, digital storage scope oscillator or CRO. After that we require DPCM trainer kit, and next one is a connecting wire as per the requirement. Now in this DPCM practical, means differential pulse code modulation practical, we can see input signal, after that sampling signal, after that encoder output, which is nothing but the differential output, after that demodulator output without filter and demodulator output with filter. Demodulator output without filter is nothing but the output of reconstructed output, and demodulator output with filter is nothing but a output of low pass filter. Now we will see a trainer kit of DPCM. Here this one is the trainer kit of ADPCM, means we can by using same kit we can develop a DPCM as well as ADPCM. Here a notch is on DPCM, means by using this kit, trainer kit, we can see the practical of DPCM, means differential pulse code modulation. After that there are sampling frequency select. Here three frequencies are available. First one is a 8 kilohertz, next one is a 16 kilohertz, and last one is a 32 kilohertz. In our practical we select a sampling frequency which is 32 kilohertz. After that here signal generator generates a original information signal or message signal which is a continuous time analog signal. This signal is connected to the input here. After that the input signal and differential output, these two signals output we get at the output of 8-bit DAC. Here we get a modulated signal, and this modulated signal we applied here input terminal of LPF, means low pass filter, and at the output we get a modulated signal. Now we will make connection. Now here we will firstly observe a information signal which is a continuous time analog signal is connected to a positive probe of CRO, and negative probe is connected to a ground. Now we will see output on CRO. Here this one is the information signal, means our input signal. Now we will draw this signal. Here input signal is a continuous time wave signal. Now a sample signal, which is here we can use 32 kilohertz sample signal, which is nothing but a train of pulses. This one is the sample signal having frequency 32 kilohertz. After that we can observe the encoder output, which is nothing but the output of differential output. Now we will see a differential output. Now input signal is applied to this input terminal, and we can observe a differential output. Differential output is nothing but a digital signal which is in the form of 1 0 0. Okay, after that here we will draw a digital signal which is in the form of 1 0 1 0 1 1 0 0 0. After that we have to observe demodulator output without filter, means the output with some added noise. After that we can connect a reconstructed output to a CRO positive probe, and ground is connected to a negative terminal. Now we will see a demodulator output. Here demodulator output without filter is a sine wave, means original information signal with added some noise signal. Now here demodulator output is sine wave with some noise signal. This is the output of demodulator without filter. Now last we have to observe the output of a demodulator with filter. Means here we can see the output of reconstruction filter, and here we can see the output of LPF, means low pass filter. Now here we will connect output of low pass filter to a CRO probe. Now this one is the our output of low pass filters, means demodulator output with filter. Now we will draw the waveform for demodulator output with filter. Here demodulator output is nothing but a continuous sine wave without any noise signal. We have to observe this signal in the practical of DPCM, means differential pulse code modulator.